And I'm here leading a research group at GFZ on the topic of geothermal reservoir engineering, and I'm also a junior professor at TU Berlin on the topic of reservoir engineering. And the use of hydrocarbon wells for geothermal, I already worked on this topic some years ago in the Netherlands, where we were looking into possibilities of co-production of gas and geothermal. Here in this project, our focus is not really co-production, but it's more on the extension of the life of existing wells. Okay, so welcome again on behalf of the whole TRANSGEO consortium. Julie, maybe if you can change the slide to the agenda. Here you see the agenda of today. I will introduce briefly the overall topic and our project in the beginning, 10-15 minutes, and then we have about half an hour where different people from our consortium will present basically all the aspects that we are working on, from the technical aspects to the economic aspects, social aspects, policy aspects, legal, and finally also case studies and strategy and action plan that we are working on, and where we would also appreciate very much your input during the course of the project. Can you go to the next slide, please, Julie? Thanks. And the next one. So we start with an overview of the project. And what you see here on the picture is a part of the team during a field trip in Croatia, in Mihovljan. And you see what we are working on. You see an old oil well in the foreground, our team, and in the background, you see buildings. And this is exactly the situations we are looking for. Old wells which may be reused for heating, especially for heating of municipalities, of agriculture, or of industrial applications. And typically, this situation is relatively rare, where you have a well which is in a still good condition to be reused and which is close enough to the heat consumers. Julie, next. Yes, so some motivations why we are looking into this topic. First motivation is clear. We have a lot of old oil and gas wells in Europe, in Germany, in other countries. In the whole world, we have about 29 million old and new oil and gas wells. So that's a huge number. And here in our area that we are looking at, Germany, Hungary, Austria, Croatia, and Slovenia, we have more than 30,000 wells. And of course, one motivation is to prolong or to extend the life of these existing wells and thereby reducing the environmental impact and many other aspects. One aspect is the cost of the wells, which you see here exemplarily. Drilling deep geothermal wells cost millions of euros. And even though the graphic that's shown here on the right-hand side is a very old one, and it's for the US market, where drilling is much cheaper than in Europe, it still shows you nicely that the deeper you drill, the higher the costs will be, more or less exponentially. And that means we are always talking about millions of euros for drilling new wells. And these drilling costs are typically 50% or more of a total cost of a deep geothermal project. And so one idea of reusing existing wells is to save money for drilling. The other bottleneck, or the main bottleneck of geothermal, is on the one hand these high investment costs, and on the other hand the risk associated with it. And with risk, I mean the risk to find the hot water that you are looking for and that you want to use. So you spend in the beginning of a project millions of euros for drilling an exploration well without knowing very well how much hot water you will be able to produce in the end. So by using existing wells, we have already this information. We access already the reservoir, and we know we have a better idea how much energy we can get out. So we reduce significantly this exploration risk and can therefore much faster, cheaper, and with less risk develop geothermal projects. And this is basically our main motivation here in this project. And this is the main motivation for well reuse. So we tackle this this well reuse challenge with 11 partners from 5 countries in the frame of a regional development project called TRANSGEO. And we received, we have a budget of about 2.6 million euros, from which 80% is funded by the European Regional Development Fund through the Interreg Central Europe program. You see here a map of Europe, and highlighted is the Central European area with all the project partners. And you see that most of the project partners are actually coming from the southeast of the Central Europe area. And additionally, we have GFZ and LBGR from Germany. GFZ is the lead partner, and you see also the link of the website where you get most of these information as well. Okay, we are a consortium of very different partners. We have research centers like the GFZ. We have universities like University of Pécs or University of Zagreb. We have oil companies like Oneo, startup companies who really focus on the reuse of existing wells like Greenwell. We have authorities like LBGR. We have owners of wells like BVH, non-profit organizations, regional energy authorities, and so on. So it's a big mix of partners with different backgrounds, and additionally, we also have a number of associated partners listed here. What we try to answer with this project is mainly what is the potential for geothermal energy development from mainly oil and gas wells in Central Europe, and how to exploit this potential. And you see again here our different work packages, a bit rearranged. You see in green the parts which are already done and where you can see the reports on our website, the policy and legal analysis of the 5 partner countries in the EU, and also the economic and technical analysis of the different reuse options, which are published on the website. The rest we are working on at the moment on all the other topics. That's why they are orange. We have a huge database of the 4 basins in our program area. We developed a criteria catalog to say which conditions does a well need to be a candidate for reuse. We developed an online well selection tool to detect the most suitable wells, and we are also working on a regional assessment of well reuse in our area, and we are working on local feasibility studies. So regional assessment telling how many wells and which ones are potentially suitable in our program area for reuse. And the local feasibility studies really go into detail at 8 sites and regions how to develop a project locally. And all this leads into a strategy and an action plan, and hopefully more implementations of well reuse than already exist, etc. Here you see a map with the different basins and our sites, our pilot sites. We are dealing with the North German basin, with the Molasse basin, the huge Pannonian basin, and also the Vienna basin. And in all these sites, Großschönebeck, Lausitz, Ampfing, Pomoje, Weinviertel in Vienna Basin, Hungarian Great Plain, Juhovian, and Zagreb-Savica. We are testing different technologies, or we are doing local feasibility studies for different technologies. And what these technologies are, I will show in a minute. We are basically looking into the whole suite of deep geothermal technologies. So that means we have an abandoned well, or we have a well which is soon to be abandoned, and we can use it either with a closed system. That means we don't produce hot water from a geothermal reservoir, but we just circulate fluid in a closed loop in the well shown on the left, or we can have open systems, hydrothermal energy systems, where we produce hot water from a geothermal reservoir and re-inject the cold water after extraction of the heat. And we also look into the heat storage options, aquifer thermal energy storage, where we can store hot water or cold water in the subsurface, which is one of the only options for storing really large amounts of energy. And also we look into BTES, which is the borehole thermal energy storage, meaning that we store heat in the rock mass by conduction. And lastly, we are also looking into the possibility of enhanced geothermal systems. That means it's an open system where we need to create a fracture network in the subsurface to be able to flow the water through the subsurface. And this is more exotic application, but it has the largest geothermal potential of all these. So the typical reuse cases are hydrothermal energy, open systems, and deep borehole heat exchangers, closed systems. And I will go in more detail later. What kind of wells we are dealing with? A wellbore can be still active, so still producing oil or gas. It can be shut in, meaning no oil or gas production. The well is closed and waiting for further decisions. Or it can already be abandoned. You see on the right-hand side where the well is already cemented, it's closed, the top of the well is cut off and sealed by a steel plate, and the soil is already renaturated in the surface. So we have these three main conditions. And of course, most suitable for reuse are active wells, which are still producing, or the shut-in wells. And the idea is to extend the life of these wells after the oil or gas production by producing hot water or installing a borehole heat exchanger. But it's also possible to use an abandoned well, like the one shown on the right-hand side, and recover this well again. And this is, I'll show you an example for this later. Good. Now we start with the first work package, engineering workflows and geothermal reuse technologies. First, I want to show you a general overview of what to do when reusing a well. I want to say that all these slides you will get after the meeting. Everyone who subscribed to the mailing list will get this presentation as a PowerPoint, so no need to write many things down or things like this. So I divided this in mainly 7 steps. And some of these steps are, of course, the same as when drilling a new well, but some are different. So initially, the first step is the feasibility assessment and the business model. The most important here, you need the data to find out if a well is suitable and if the geology is suitable for reuse. And you need a customer for the heat. So this is the most important, because the well locations are fixed. The question is there a customer nearby? And this is one of the biggest bottlenecks. And then in the beginning, you would identify potentially suitable wells. And then you would do an initial feasibility assessment before spending much money for a detailed feasibility study and finally making your investment decision. One other challenge is if the ownership of the well or the license needs to change in this process. If not, the well owner wants to reuse the well, but another company wants to reuse it. This is possible. It can be done with private contracts. The challenge here is how to handle liabilities from the previous operations. And you also need to handle the licenses for the heat production. Sometimes also for oil and gas production, if you're producing both at the same time. And you also need the permits for your activities, work over, well testing, and so on. And the third step, most importantly, is the re-evaluation and reconditioning of the well. This can mean that you need to construct a drill site again, sometimes not, but mainly you need to perform logging operations to determine the integrity of the well and also the shape of the well, which is very important for installing any new equipment in this wellbore. You have open system, you need to perform hydraulic tests. And if the well is closed already, you need to reopen the well, you need to possibly drill the cement plugs, you need to clean the well, maybe you need to repair it, maybe you need to plug certain parts of the well back, and so on. So this is the important technical part, the reconditioning of the well and evaluation whether a well is suitable or not. And this can be done relatively easily with logging and integrity tests. Then the rest, well completion, there are different options I discuss later. And the rest is more or less the normal procedure. You install your surface infrastructure. It would be best if you have already some district heating network in place, and then you perform your long-term operation over a duration of maybe 20 or 30 years, and then eventually you need to plug an abandoned well. And for this, you should have a proof of the financing for this and the expertise already at the beginning of the project. Okay, so briefly about the two general technologies, closed systems and open systems. For the closed systems, ball heat exchanger, you see here a typical example on the right-hand side. You inject cold water and it heats up, and in the center of the coaxial pipe, the hot water is produced to the surface. These kind of systems are a classical reuse because they are also easy to do and well predictable. The problem is you don't get much energy out, typically only in the range of 50 to 500 kilowatt. Can also be more depending on the well length and temperature. And this is economically challenging. You would never drill a new well like this with current drilling costs because the costs are too high for the energy you get out. And even for reuse, you have costs for typically more than 100,000 euros for reassessing and repurposing the well. And in the end, you still need to plug and abandon the well, which again costs a couple of 100,000 euros. And additionally, you have operating costs of a couple of 10,000 euros per year, and your revenue is only a bit higher than the operating costs. And this shows you already that it's economically challenging because you don't get much heat out of these closed systems, but they are a relatively straightforward way to go. And if you can operate the well for a very long time, it becomes more and more feasible. To become economic, the well should not be abandoned yet. In the best case, the well abandonment is already financed. The heat consumer should be very close by to avoid the high cost of long district heating lines. The integrity and the diameter of the well should be confirmed recently already by logging. And it's cheaper to use polyethylene pipes than steel pipes, but they have a temperature limit, these polyethylene pipes. And of course, a high geothermal gradient and thermal conductivity helps. Opposed to this, open systems, we have basically four options: co-production of oil and gas and water, water production from the oil or gas reservoir after the oil and gas production time, deepening into a geothermal reservoir or perforation of or access of a shallower geothermal reservoir. Co-production, you can basically produce already, or in many cases, oil companies produce already a lot of hot water. This can be more than 10 liters per second, leading to typically more than 2 megawatts thermal energy. You just need to install a heat exchanger. The challenge is that usually these wells, there's no customer nearby. Then if the oil and gas production is already stopped, you have the problem that the reservoir pressure is very low after decades of production. So these wells may be good use for re-injection wells. And you have a low relative permeability of the water due to the residual oil and gas. That means it's best to use failed oil or gas exploration wells which did not find oil or gas actually, because then you don't have a permeability reduction due to the gas and oil which is stuck in the pores. Okay, for the other two options, you have the challenge of the small wellbore diameter, which can lead to friction, increase the frictional pressure losses in the well, and the excess of shallower aquifers through multiple casings and multiple cement barriers may be challenging. Okay. Now I'm already over time. Last slide. One example of Groß-Schönebeck, which is our GFZ owned and operated research site. Here we had one gas exploration well, which was not successful. It's shown in the middle schematically, very small. And this well was already abandoned, and there were 3 cement plugs drilled out. The well was recovered, and the well was even deepened. And the overall cost for this was 1.5 million euros back in 2003. 2006, a new well was drilled next to it, and the cost for the new well were 13 million euros, so much, much higher. This is mainly because also the drilling took much longer than it was planned, but it also shows nicely that the costs of drilling new wells can also increase due to drilling problems, especially when you're working in a new area where not much drilling has been done in the past. Yeah, I think this is it. I just wanted to mention the link. We have a study already published in Geothermics on the Groß-Schönebeck reuse case, so you can find much more details on this site. Good. So Tori, sorry for taking so much time already. Barry, now you can continue with the criteria catalog, database, and well assessment tool. Thank you.
Thank you, Hannes. My name is Ferenc Fedor, and I'm a geologist engineer, and I am one of the professional managers of this project. And our team is responsible for writing the criteria catalog, integrating the Excel-based data into a relational database, and creating the so-called well evaluation tool software. And the 3 tasks are closely linked. What does it mean? In case of criteria catalog, we have to summarize evaluates and weights all relevant factors. After, we have to collect on the basis of the criteria catalog the data and integrate it into a relational database. And on the basis of the criteria catalog based decision tree and the data which we have, we developed a so-called well assessment tool, which help us to search and link the best wells for the given purposes, for the given geothermal purposes. Please, thank you. You can see the decision tree which we made on the basis of the criteria catalog. So we have 5 technologies, and we have to decide different. We have to answer different questions and decide something. What is the goal of the renewing of this well? We have a well or a market. We would like to store the heat or only production. Product is what is the status and integrity of the well, and is the well in protected areas or no, which market we have, and we have to answer we have to answer many different parameters. So we have to find which well is good for which purpose. For example, in case of BTS technology, there are many irrelevant factors, but we need relatively high temperature, but not too high, and middle depth, and a relatively good permeability, and the maximum casing is higher than 7 inch. Next, please. Here you can see the flowchart of database. We differentiate 3 different type of data: data from wells, data from geological circumstances, and data from market. And we try to summarize and collect all the data. However, we know very well that it's a huge work, and sometimes we have to make some compromise. Next, please. Yes, now we have more than 22,000 wells and more than 160,000 data records, but it's improving in the time. Please, next. Here in this slide, you can see the data flow of well assessment tool. So we have lab measurements, reservoir data. Sometimes the raw data we have to export to the GIS system and uniformize the coordinates. After we reload this new data, this data set to the well database, and on the basis of a well rating algorithm, we can find the best well for the best purpose. And next, please. You can see very preliminary example of this. It's a Hungarian example, but it's not the final version. When we choose the hydrothermal systems, potential abundant wells for this purpose, and on the basis of this feature, we can see that the green means that it's a potential and good well, so we can use it. The orange means that we have to investigate that wells in more detailed, but potentially they are good. And the red means that for this purpose, that wells cannot used because of different reasons. So that's all. And if you have any question, I try to answer at the end of this presentation. And at the end of April, we hope we have the final version of this tool. Thank you.
Thank you, Philippe. Next is Matej talking about the socio-economic analysis for the different target groups for different applications.
Yes. Thank you for the word. My name is Matej. I'm the representative of Leo Pomoria. Can we go next? What we did, until now, we analyzed 3 potential groups that could be potentially interested in the reuse technologies represented. The main sectors we focused on were industry, agriculture, and municipalities. What we recognized was that partner countries have some differences, but also similarities, which are depending on the region and the partner country. For example, like geothermal sources in sight of depth, chemistry, yield, temperatures, pressures. Social view of acceptability and challenges, which are mainly related to social experience of people which came across with research drilling, for example, or hydrocarbon production operators. Economic feasibilities related to actual situation in the wells. So basically, if there are some data available and if those data is also reliable. And with this, it's a good help to achieve the planned goals. And also what we learned, that we have some good practices. And we already have some examples of reuse, which are still in production today. Next, please. Additionally, we performed an analysis which mainly dealt with demand patterns, feasibility, and target groups. We realized that there are certain patterns of heat energy demand for heating, which could be covered with the help of reuse technologies. Two demand patterns examples are presented on the left above and right below. The left above represents a district heating system demand, and the left below presents a greenhouse and the demand of heat and cooling in the yearly season. What we also find out that quite a significant energy demand is in the industrial sector in all countries, but the industry in some cases for processes needs quite a lot of energy and a lot of heat. So regarding to that, there are some certain limitations, and it's not easy to provide all the needs with the reuse technologies. Next. As already described, during the analysis, we also determined the energy potential of individual technology that we see as potentially applicable. And what we find out that there are existing wells which can be reused, and beforehand they need to meet certain conditions. What we can see from this slide is that the major, or let's say the highest potential is recognized in the hydrothermal energy and the EGS applications, but also ATES as a technology is not negligible. Next, please. We also did an economic assessment or evaluation. In that, we tried to estimate the cost for workover of an abandonment well, what you see here. What we saw is that we have a significant difference in the regions with pricing. And the numbers that you see here are basically covering the minimum interventions on the wells with no special services. So that is important to emphasize because significant differences can occur when workover is performed, mainly due to specific characteristics and location specifics of the regions and self-service resources. Next, please. We also tried to understand what would be the cost impact of surface equipment. For that, we stripped down the minimum requirements to install in the reused wells, such as downhole pumps, production strings, surface installation for distribution, heating exchangers, and metering systems. Here, again, similar than in the previous slide, it's important to understand that a lot of things need to be considered and specific characteristics are driven, or let's say are important to have in loop beforehand to understand the whole impact of the cost. Thank you.
Thank you, Matej. And now we go from the economic analysis to the legal analysis and the policy framework presented by Monika.
Hello, everybody. I'm Monika Hölzl. I'm the representative of Geosphere Austria, which is one of the three Austrian partners in the TRANSGEO project. We made an analysis and a comparison of the legal, administrative, and financial framework, especially for reuse and for geothermal applications in general. Our aims are to document and to present the differences and similarities of the framework at the country level, and we want to provide best practices for policy regulations to identify bottlenecks and give suggestions for improvement. And we focus on the subsurface, I have to add at this point. And all our results from this activity should be applicable or are applicable at a transnational level afterwards. So some words on the method. How did we do this analysis? We divided our topics into 3 chapters, which are legals, administratives, and financials. Internally in the group, we worked out about 50 questions, which were answered then step by step by the 5 partners of TRANSGEO. And now with the next slides, I would like to pick out some of the examples of answers we have collected. First, the legal chapter. We asked if there are licensing systems for geothermal energy production in the partner countries. It came out that in 4 countries there are licensing systems existent, and in Austria it's not existing. Another important topic is the regulation about the well ownership. Who is the owner of a well after it's drilled? So there are usually the permit holder or the operator is the well owner, but in some countries the state can own a well as well after the operator steps out. This is the situation in Hungary, Croatia, Slovenia, and Germany, and not in Austria. With the question of well ownership, there comes the questions about the well transfer, how to transfer liabilities. Is it possible? If yes, how is it possible? Is it complicated, or is it an easy system? We came out with the conclusions that in Hungary, Croatia, Slovenia, and Germany, the transfer of ownership is possible. In Hungary, for example, it's even regulated by the State Property Act. And in other countries, you can do the transfer with a contract which is simple or not so simple. In Austria, the well ownership, the change of or the transfer of liabilities is not so easy. Normally, the owner changes only with the overtake of the license, and we speak here of the overtake of a hydrocarbon license. Another big topic is the data, the ownership, the access, the storage. There are huge similarities in storage, who collects which kind of data, and how is it accessible by an interested investor. For example, in Hungary, basic well data are free, and detailed data can be purchased, and there is a one-stop shop system where you can apply. In Germany, basic well data is free, other data can be requested. In Austria, data is not free. There are certain services by the ministry where you can look at data or connect via web map service, but in detail, well data are in the ownership of the companies, and you have to request and normally pay fees for the data. So the next chapter is the administrative chapter, which includes the big topic of permitting, and we have analyzed as an example the permitting workflows, how they look like in the different partner countries. And the example I have plotted here is how many entities are involved in the permitting processes. And we talk here about general geothermal projects. So because for reuse, it's very different. And so we have taken the general geothermal projects. Hungary has a one-stop shop system since 1.5 years, and you can apply online. So it's fast and efficient. The other countries, there are variations in the application procedure. Normally, more or at least 2 authorities within ministries are involved. And the applications for approval are depending on your project and on your project place. So for the financial framework, on the next slide, please. We categorized our funding methods into national funding, then others and alternative funding, and incentives. So it came out in Hungary and Austria. There are national fundings, direct national fundings for well reuse. In the other countries, there is nothing. There is only indirect funding, like tax reliefs, for example, or there are fundings for geothermal applications in general and not explicitly for reuse. The other or alternative fundings, they include European Union fundings, non-EU fundings like the Norway grants, crowdfunding, energy communities, etc. And they cannot be found in Austria. In Hungary, that's a typo. There should be a yes. And the last block was the incentives, where it's meant, for example, if there is a support for companies to locate or invest somewhere, and we could only find support in Hungary for this kind of funding. So our conclusions. The conclusions, the outcomes, the barriers, and the next steps are that our analysis has shown that there are not really legal barriers to well reuse. We have identified the largest barriers as financial, as the application is very complicated. And another chapter was added, like the social barriers, that the social acceptance is and the information should be improved. So we must raise awareness and improve the access to data and information about the availability of wells and how they can be reused. And a very important point would be a requirement to consider reuse before abandonment for strategic planning for companies as well as on the national and EU scales. And all these points, which I mentioned before, go into a TRANSGEO strategy and an action plan. And we will provide detailed recommendations to accelerate the well reuse topics in the future. And below you can find the policy analysis report, which we finished last year, if you want to have more detailed information on this topic. Thank you.
Thank you, Monica. We have, I know the 45 minutes are already over, but we have 2 more aspects that we would like to discuss, and the discussion in the end we will extend accordingly. So next is Tomislav talking about feasibility studies in this project.
Thank you. Greetings to everybody present. My name is Tomislav Kurevia from the University of Zagreb, Faculty of Mining, Geology and Petroleum Engineering. I will shortly present you our activity that is right now ongoing. It is related to site-specific feasibility studies related to well repurposing. So we have 8 pilot sites with abandoned hydrocarbon wells. Of those that you see here, 3 are typical hydrothermal energy system from Germany, Hungary, and Croatia. We have 2 borehole heat exchanger principles, and we have 1 borehole thermal storage location, 1 enhanced geothermal system, and 1 aquifer thermal energy storage. So these feasibility studies generally will serve as a validation and realization of previous activities, which you can see here amongst criteria catalog, well assessment tool, and engineering workflows for all 5 geothermal reuse technologies. Furthermore, these feasibility studies will serve as the investment decision at the pilot sites. And what is important to say, this will happen after the project implementation. Next slide, please. I will just give you a brief presentation of the feasibility study, which is currently ongoing for the oil field Mihovljan, which is based in Pannonian Basin, northwest part of the Croatia. This pilot site addresses hydrothermal heat production from the mature oil field Mihovljan, which will be abandoned after oil production ceases. It's a question when, but it is among oldest fields in Croatia where oil is still being produced. But what is important to mention is that the Mihovljan contains small, thin sandstone geothermal brine layers above oil saturation layers. So we are not developing oil layers, we are developing shallower thin sandstone layers, which we believe that can serve as the small pilot cases for geothermal energy. So idea basically, since this oil field is very near the town of Čakovec and other villages, that it could be retrofitted after the oil production ceased to be a small district heating network, or to provide geothermal heat to the agricultural sector or in greenhouses. All of our feasibility studies that will be on 8 sites will have a following content: geographic location analysis of spatial planning documentation, When talking about Mihovljan, we will analyze entire well database analysis, which can be found in Croatian Hydrocarbon Agency. This is one of the agencies that is holding data in Croatia. What we will see is the well construction, geological, geophysical works in well, special operations, production tests. Also, we will make a geological structure of the geothermal reservoir in the shallower layers above the oil-bearing layers. We will define production features, possible production features of the potential location, with quantification of possible brine production. Also, we will tangle environmental features of the projects from the perspective of the environmental impact, and also, what is most important, doing techno-economical analysis to see what would be the cost to retrofit this oil field. All studies will be available during fall, and then eventually as deliverable will be presented in winter 2026. Next slide. Thank you. So this is just a shortly presentation of currently ongoing process. As you can see, we have 11 well channels drilled in the Mihovljan oil field. Of those channels, only 4 are remained active, although the oil is producing just from one well, other are currently shut off. What we are proposing is to have 2+2 production injection wells, Mihovljan 1 and Mihovljan 7, and Mihovljan 3 beta and Mihovljan 6 wells. From the production analysis, which is inflow-outflow classical oil production engineering analysis, with some sensitivity analysis performed on average reservoir permeability, we came to conclusion that somewhat 5 to 8 liters per second from each of the well would be possible with implementation of electrical submersible pumps. The temperature at the wellhead would be around 80 degrees Celsius. This is coming from mid-permeable mid-permeable sandstone layers, which have a permeability of around 10 to 20 millidarcies. It's not high, but with this thickness of around 35 meters, this production would be possible. So as you can see from the above left picture, all of the wells are basically above the settlement Pribyslavec, which is a small village next to the Čakovec, and there is a tremendous agricultural area around wells where also it could be used maybe in greenhouses for heating purposes. What is most important, we will do analysis of production injection pumps power capacities, because these are parasitic loads to the projects, and what we want to achieve is the best possible case scenario for the seasonal performance factor, which is the perfactum that gives you a comparison between how many electricity you pour into the system to power up production injection pumps on the other hand, and how much you can get the geothermal heat coming through from the reservoirs. So this is a basic CAPEX OPEX interpretation. We hope that this feasibility studies will show us the possibility of retrofitting all of these 8 sites. And for more details, you can always contact us on the previous mails and lists if you're interested in details. Thank you very much.
Thank you, Tomislav. Then we finish with Emma on the Transnational Strategy and Action Plan.
Thank you, Hannes. Hello, everybody. My name is Emma Novak. I'm a project manager from MENEA, and I will shortly present to you the Transnational Strategy and Action Plan, which are under the coordination of MENEA within the project TRANSGEO. Next slide, please. So first, we have to answer to the question, why is strategic planning important within this project? With these processes and documents, we would like to highlight the importance of repurposing abandoned wells for energy use rather than drilling new ones or using the current fossil fuels for energy production. Of course, within our documents, we are going to highlight and identify all resources which are missing in the process of reusing currently abandoned wells. And when I say resources, I mean human, legal, financial, technical, and every other resource which is needed in the process of repurposing wells for geothermal energy use. Our documents are therefore certain summaries of all findings and ideas, recommendations, results, and everything else that you have been listening about from my previous colleagues. And we consider them to be the beginning of certain changes on transnational level, because all of our partner countries and the transnational Central European countries have many geothermal potential and the potential to abandon to reuse the abandoned wells, but maybe they don't have the appropriate guidance. So with our documents, we would like to provide them the advice and guidance how to do that more easily. Next slide, please. The first document, as you can see, is the more extensive one. It is the transnational strategy, which is going to combine the topics which are listed in this colorful table. The first topic we're going to address are the current features of geothermal energy utilization in our partner countries, and this is going to be performed through strategic, legislative, and legal frameworks analysis. After that, we're going to examine the geothermal potential of the Central European regions, meaning our partner countries, and after that, we're going to narrow it down to the well repurposing potential. Of course, such projects have significant impact on the environment and the biodiversity, and that's why we would like to dedicate one chapter of the strategy to examine how exactly well repurposing influences the environment and biodiversity in the regions where it is implemented. As you know, such projects tend to be, of course, financially a bit exhausting, and therefore we're going to also highlight the most important financing opportunities and resources on transnational, national levels, regional, local, the traditional ones, the innovative and alternative ones, which have been mentioned before. And the two, I would say, most important chapters within our strategy are the challenges and strategic objectives and the implementation recommendations and measures, within which we are going to identify all the bottlenecks and shortcomings of well repurposing in our partner countries, and we're going to recommend certain objectives and measures to tackle them. These two chapters are going to lead to mainly to the development of the transnational action plan. Next slide, please. This document, so the transnational action plan, is a little bit more detailed than the strategy, because the basis for its creation is, of course, the strategy and the feasibility studies and the well assessment, which you have been listening about before. But it elaborates in more detail all the priorities, objectives, measures, and everything that has been identified within the TRANSGEO project to be a hindering aspect for well repurposing. These measures within the action plan are going to be elaborated in detail through extensive activities, all resources meaning legal, human, timely, financial, and every other resource which is needed to implement this measure. Of course, we're going to include certain stakeholders, give some financial assessments and timely assessments for well repurposing and for the implementation of the measures. And in the end, we're going to count down some indicators of success, and we are going to highlight what exactly we would like to achieve with this measure and all activities which are needed for its implementation. I would like to conclude my part of the presentation by saying that our documents, so the action plan and the transnational strategy, are observed as certain guidance documents which are aimed to the local, national, regional, and every other authority which in our partner countries, of course, the companies, meaning drilling companies, oil companies, agriculture, sales, and every other company which is currently included into this project. Of course, the general public, development and sectoral agencies, so basically every stakeholder and listener which is here today. And with these documents, we would like to give you certain guidance and advice how, if you have this possibility in your regions to address the problem of repurposing abandoned wells, how you can easily repurpose and use the geothermal potential in your region, and of course use the geothermal energy once in your production, consumption, and daily life. Thank you.
Thank you, Emma. Then I would like to conclude our overall input to this workshop here with reference to the deliverables that are already published and online on our website. And you see the deliverables which are in preparation. You heard about them already during the presentations. From my side, the whole concept I would like to summarize with everything you need is a deep well which is in a good condition and for which you have good data, and where you have next to the well heat customer. That's all you need, but these kind of situations are not very often there. But if you have it, typically you can save half of your investment cost by reusing compared to drilling a new well, and anyhow you significantly lower the exploration risk. And especially if you are new to the topic, you need to take special care about liabilities in this process. Okay, Julie, then it's your part now.
Okay, great. So hello everyone, you can hear me?
Yep.
Good, okay. So I'm Julie Friedel. I'm the project manager for the TRANSGEO project. And as I mentioned at the very beginning of the presentation today, I am your contact for engagement. So if you would like to get in touch with us regarding any opportunities to work together with us on any of these 6 different pieces, excuse me, that we've just shown you, or come to any future meetings that we will have, please feel free to get in touch with me if you're not already on our mailing list. So today I would just like to provide a little summary of the topics and the outputs that we are looking for your input on. So you learned today about the well assessment tool from Ferry, and as he mentioned, it should be available this summer for in a final draft form. And we would like to know if it is actually useful to you, how you can use it, if there are tweaks that you would think would be made to it that would be helpful to you for your work and for well repurposing in general. So we hope to have that ready by the summer and available to you. We will be sending out emails and also LinkedIn announcements, as well as announcements on our website for all the different pieces that I'll be talking about right now. And as Emma mentioned also, our transnational strategy and action plan will be available in the fall and then in the winter for your input. And for the strategy, the well assessment tool and the strategy in particular, we have webinars like today's webinar that we will be hosting in September and October later this year, where we would present the strategy and also in the second one present the well assessment tool and invite your feedback and input for improvement before they're finalized. So we hope that you would be able to join us for these upcoming webinars, as well as our final conference, which will happen in April 2026. So our project runs for just over 1 more year, and we would like to have a large gathering for the final conference to be able to share everything that we have produced, as well as look forward to the future and future projects of actual development of new geothermal energy sources and projects and reusing wells. So in addition to these larger webinars and final conference, we also are planning over the coming year more than a dozen different focused specific workshops on our actual well assessment. So the answer that comes out of our well assessment tool, so which of these 22,000 and more wells are actually good targets for reuse. We'll be presenting these workshops across the region in the summer and fall of 2025, as well as pilot site workshops on the 8 pilot site feasibility studies in the locations of each of the pilot sites. So these will also be happening later this year. And then the transnational action plan workshops, once the action plan is available, we will be sharing it and inviting your input and collaboration on implementing the actions that we are recommending. So the stakeholder meetings that we have planned so far are going to be held across the 5 TRANSGEO countries. And a few that I can give you a heads up on today are the European Geothermal Congress, which will be held in Zurich in October, as well as the German Geothermal Congress, which will be held in Frankfurt in November. And also we have involvement at the Dubrovnik, Croatia Summer School on Petroleum Engineering and Geothermal Energy, which will be in June in Dubrovnik. And also we are planning these local pilot site workshops at each of the sites. So as I mentioned, announcements will be made on our website, on our LinkedIn, and also via the email list, which if you are not on the email list, if you have not been receiving emails directly from us, please contact me at any time. My email is in the chat, and it will also be at the on the last slide of this presentation. So please feel free to be in touch anytime with me or others in the project if you have special interest in any particular topic, product, or meeting.
Good. I end the poll now.
Okay, and share the results.
Share the results.
Yeah.
I think you should see this now. So the winner is deep bore heat exchangers. No, where's hydrothermal? Here. Deep bore heat exchanger is the winner, and hydrothermal energy second place. Mm-hmm. Actually, aquifer thermal energy storage and borothermal energy storage, to our knowledge, there exist no reuse projects so far. So the only reuse projects that exist are actually deep bore heat exchangers, EGS, and hydrothermal energy. And mostly they are concerning failed exploration wells, because they have the best conditions. Yeah. Good.
Okay.
Thank you for taking part also on the poll.
Yeah. And this is a final slide of questions that we would use to initiate discussion had we not had enough. But these are some things you can keep in mind for future engagement with us or with well reuse in general. So I think today we need to wrap up, but we ask you to please engage with us. If you are interested in working with us on the TRANSGEO project, please write to us, join us on LinkedIn, or look at our website for the deliverables and reports that have already been produced. If you're interested in engaging or providing your input or feedback on our upcoming tools and deliverables and reports that we're producing, we would be extremely happy to hear from you. Write to me anytime. You see my email at the bottom left, julie@gfz.de, very simple email. And thank you so much for joining today and for staying through the hour and a half. We hope that you enjoyed the information that we've shared and hope that we can work with you further. And I'll turn it to Hannes for the final word.
Yes. Thank you, everyone, again. On behalf of the whole consortium, you have seen we are looking into this topic from many different angles, and it's definitely not over after the end of this project. This whole topic. Good. Thank you, everyone, and looking forward to see you at one of the other meeting occasions, and hopefully also in person and not only in an online webinar.
Okay. Thank you all.
Thanks.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you.
Bye.
Well done. Thanks.
Thanks,
Bye.
Angel.
Bye-bye.
Bye.
Bye.